All right, welcome to section 4.2. We're going to talk about the real zeros of polynomial functions. And last time, remember, we found how we could see if something was a real zero of a function because either it was already factored, which is very nice, and we love those problems, or you could easily factor it. But sometimes you can't easily factor something, okay? So if something were a factor, remember when you plug that value in, so let's say you wanted to see if r was a factor. So when you plugged r into the function, you got f of r equals 0. And that told you that r was an x-intercept and that x minus r is a factor. So now our remainder theorem says that if we have this function, a polynomial function f, and if we take that polynomial function and divide it by x minus c, or in other words, you factor it by this, the remainder is going to be f of c. So in other words, that value that you're trying to check to see if it goes in, if you put that into the function, f of that value tells you what the remainder is. So coming down here, I've got this polynomial, and I want to divide it by both these binomials. So on this first binomial, if I put this in, I want x plus 2 is the binomial, so that means the x-intercept that I'm checking is x equals negative 2. Remember, set that equal to 0, solve for it. So I'm going to plug in a negative 2 into this function. So let's take a look here. F of negative 2, what does that equal? Oops, sorry, I turned. So negative 2 to the third plus 3 times negative 2 squared plus 2 times negative 2 minus 1. And again, go ahead and make sure you're putting these parentheses in, whether you're doing it by hand or in the calculator, to make sure you end up with the correct signs. So negative 2 to the third is negative 8. Negative 2 squared is positive 4 times 3 is 12. 2 times negative 2 is 4, and then minus that last 1. Don't forget that. And this gives us negative 1 as an answer. So my remainder for x value of negative 2 is negative 1. Likewise, let's try the second binomial. If I want to check x minus 1 as a factor, that means that the x-intercept is positive 1 that I'm checking. So now to see if there is a remainder, or see what the remainder is, I'm going to take that value and plug it into my function. So I'm going to get 1 cubed plus 3 times 1 squared plus 2 times 1 minus 1. And hopefully you're like me, you like seeing lots of ones. It's easy to work. So 1 to the third is 1 plus 1 squared times 3 plus 1 times 2 minus 1. And this gives us a value of 5. Okay, so hopefully now you recognize that maybe there's something to this. If I plug in my different x values, I get out the remainder, but that's also your y value. Don't forget that. So my factor theorem says that if a polynomial is divided by some binomial and the remainder is 0, then x minus c is a factor of that polynomial, which makes sense. So we're basically saying if f of c, so if f of c equals 0, then x minus c is a factor. Is a factor. And this is very handy. It's much easier to plug this in and see if it works. So let's take a look down here, and we're going to see if either of these are factors. And then we will use synthetic division to write it out in factored form. Because the whole idea of knowing it's a factor is we want to get down to the smallest factors of your polynomial. Okay, so let's take a look at this first one. X plus 1. Let me slide this up. So that tells me that the x-intercept, or the x value we're checking, is x equals negative 1. Okay, so first thing I want to do is plug in negative 1 into my function. So I've got negative 2 times negative 1 cubed minus negative 1 squared plus 4 times negative 1 plus 3. And when we plug these values in, negative 1 cubed is negative 1 times negative 2 is positive 2. Negative 1 squared is positive 1, but we're subtracting. Plus 4 times negative 1 plus 3. So we get a value of 0. Okay, so if my remainder is 0, this says x plus 1 is a factor. Okay, so yes, it is a factor. And we'll come back to how we use that in just a second, but let's go ahead and check negative 1 also. Or sorry, check x minus 1 to see if that's a factor. And again, this one, what we're really checking is x equal to positive 1. Is that a factor? So does it give me a remainder of 0? So we plug that in. So substituting a 1 in for x, and I get negative 2 times 1 cubed minus 1 squared plus 4 times 1 plus 3. And here we've got negative 2 minus 1 plus 4 plus 3. That equals a positive 4. Positive 4 is not equal to 0, so this is not a factor. And again, what we're checking is x minus 1. So x minus 1 is not a factor. X plus 1 is a factor. And now it says, so now that we know that it's a factor, let's go ahead and factor this. We're going to factor out the x plus 1. And the way we do this is with synthetic division. And if you need a refresher, please talk to one of us, your teachers, or check Khan Academy. But it is something you're going to want to be able to be comfortable with. So remember, with synthetic division, first thing we do is write down all the coefficients in order, and if any, you don't need to write a plus. And if any term or exponent is skipped, you have to put a placeholder of 0 in there. On the outside here, we put the value we are checking. So my factor is x plus 1, so the x value that we're looking for is negative 1. Okay, so again, these two will always have the opposite signs here. So this is the factor. I'm factoring this out of this polynomial. And we bring down the negative 2, multiply, giving us a positive 2. Add together, going down your column, you get a positive 1. Multiply, so negative 1 times 1 is negative 1. Add as we go down the column, we get a 3. And multiply again, we get negative 3. And our remainder is 0. Again, confirming what we had over here. Okay, so this gives me, this is a new polynomial right here. So this is negative 2x squared plus 1x plus 3. So this is the quadratic that when multiplied with x plus 1 gives me this. Okay, so f of x can be broken down into the factors of x plus 1, that's what we had right here, multiplied by negative 2x squared plus x plus 3. And again, you don't have to write the 1 in front of the x. I just like to do it. Okay, so now we've factored f of x into two terms. And let's talk about the steps of how we go about doing this, because how does this benefit us? And it's going to require some work, but there are some steps that will make it much easier for us. So how do we know what to try? Here I gave you things to try, but what about if you don't know where to start? So we're going to limit what you have to try. So there's 3 steps here. First step is list factors of our constant. So in your f of x, pull it down so you could. So whatever your function is, we're going to list out the factors of your constant. The constant sometimes is called a sub 0. So feel free if you want to use that, but it's a subscript there, a sub 0. And we're going to call these p, okay? And of course, there are positive and negative factors. So for instance, for 3, we have factors of positive 3 times positive 1 or negative 1 times negative 3. So those would be the factors. Those represent my possible values for p. Step 2 is list factors of the leading coefficient. And leading coefficient is a sub n. And again, you don't need to know that, but as you continue on, the subscripts and how we designate terms is important to understand. So we list out all the factors of the leading coefficient. And my leading coefficient in this case was a -2. And the letter we use to describe those is Q. And again, there's positives and negatives that could multiply together to give me any value. So I need to list all of them. So my factors of -2 are 1 times -2 or -1 times +2. So there's not a lot of values, but you'd still list them out. Finally, then you create the ratio of the lists. So I'm going to take all my P's and divide them by all the Q's. So plus or minus the P's divided by plus or minus the Q's. Remember, right here we said our factors of 3 are plus or minus 1 and plus or minus 3. This was plus or minus 1 or plus or minus 2. So the 1 divided by 1, 1 divided by 2, etc. So you can see the list can grow, but it's not an unlimited list. It is only things that you create by factors of the constant divided by factors of the leading coefficient. Okay, and let's continue on the next video.